Hi and welcome to HANSA.newscast, where we check the pulse of the maritime industry and meet the people driving it forward. I'm Janne Silton, and today I am happy to introduce Parthiban Muthukrishnan, who is Customer Success Manager in Additive Manufacturing at Pelagus 3D. Welcome, Parthiban.
Thank you, Yanni. It's a pleasure to be here and to talk to you about myself and the company and what we do.
We met during SMM and it's really exciting what you do. I think it's really revolutionizing within the maritime industry. But before we dive into the business case and technology of Pelagus 3D, could you share a fun fact about yourself that the audience might not expect?
Fun fact. I can say I'm passionate about riding motorbike. I was lucky to have ridden across 3 continents so far, and I'm looking forward to more enjoyable rides. I enjoy riding on mountain roads. Norway, I had some excellent riding trips, and then a few in India as well as in Mexico. So, yeah, that's my fun fact. And also, motorbike riding is not just an hobby for me. I take it passionately, and then I enjoy whenever I'm on the motorbike. I forget everything else and just focus on riding.
Wow. From living in Germany, where everything is very structured, just thinking about riding a motorbike in India or in Mexico sounds quite adventurous. How is the difference to Europe?
Well, just like you said, it is adventurous. So, what do you do in an adventure? You keep your eye open, and you should be expecting anything. So, you just have to be more aware than riding in in Europe. In Europe, you have a good structure. Everything is managed. Everything is planned. But in India, yes, you might expect people on the road, or you can expect animals on the road, which is not so common in Europe. So just have to be more vigilant, more aware, and not forget to have fun.
No, fun is important part of the life, I think. And now we will kind of have a look at the company and what makes fun there, because I think success and fun, I would presume, is quite closely related. Can you give a quick overview of what Pelagus 3D is doing in the additive manufacturing space and what makes the company stand out?
Pelagus 3D is a on-demand manufacturing company. So what we do is produce spare parts for our customers. The customer can be an end user who is on the vessel, or original equipment manufacturer who wants to deliver these spare parts to the customers. So Pelagus 3D acts as this hub, as the platform that connects the OEMs and the end users for the availability of spare parts across the world when and where needed.
Can you share a bit about your background, how you got into additive manufacturing and customer success?
So I'm a mechanical engineer by education, and started working as a product design engineer. I've had many different roles in research and development, product development. And around 2016, I had the opportunity to explore additive manufacturing as my side task from my regular product development work. And then I found that I was enjoying exploring this new technology of manufacturing. And for 2 years, I've been doing that while working in Chennai in India, and then I had the opportunity to Denmark to do the same, but with as a full-time role. So then I started seriously working into additive manufacturing, supporting our European customers in terms of consulting, manufacturing, and also training on the different technologies of additive manufacturing. And then had the opportunity to move to Norway in 22 for Pelagus 3D, where I'm the customer success manager, doing the same for external customers.
How do you measure customer success?
For each customer, there is different goals. So first of all, understanding the goals, the pain points for the customer is important in my opinion. So once you capture that, like what is success for the customer, and then we can work on it, and then see how we solve this issue or improve the situation. So this is success, in my opinion. And this is how we can measure it, because once you know what it is, and then we start to plan to achieve that goal.
So you have a very close feedback loop within the company.
Yes, we do. We believe in having this closed loop and managing this as a relationship instead of just being a customer service provider relationship, because this is a new technology, right? This is something new that the customer is adopting. So here you might need some handholding, some additional clarifications, additional consulting. So to do this effectively, I believe in having this close relationship method of doing things is more beneficial than having a regular customer and normal relationship.
For those unfamiliar with additive manufacturing, could you explain what it is and how it differs from traditional manufacturing methods?
Oh, yes. I enjoy talking about additive manufacturing. So, to give an idea, I'll start with traditional manufacturing. So, what do we do in traditional manufacturing or subtractive manufacturing is we take a block of material, we remove the unwanted material to achieve the geometry or the shape that we want. So, this can be either drilling, cutting, milling. So where you remove the material and you have this scrap which needs to be, all the chips, burrs, and all those things. So this is waste. So it has to be recycled then. So if you compare this with additive manufacturing, as the name states, so we add material one layer after the other to create this geometry or the shape that we want. So as you can see here, we use material only where it is needed. And of course, I'm generalizing it. In each technology in additive manufacturing has a little bit of differences here in terms of how the component is being made. But the overall principle is that you take a layer of material and you apply this energy, can be a laser source or heat source, and then you add a new layer of material to fuse it together, and then you keep doing this one after the other to achieve that final product. So this is how additive manufacturing and subtractive manufacturing differs. And obviously there are some advantages and disadvantages in both the manufacturing technologies. So this is why it's important to understand the application or the product more, so we can choose the right manufacturing process.
In regards to requirements of the method you use, is there any limitation using your method?
Yes, depending on the product and functionality, there are not 3D printing or additive manufacturing is not the solution for all the problems or for all the product requirements. So, say for example, take a shaft. We don't necessarily need to 3D print a shaft because there is no complex profile, there is no geometry, and there is, of course, we can manufacture, but in terms of a good business case, I believe if we just machine in a CNC machining process, then the shaft can be cost effective. And this is how we understand the product requirements and what it needs, and we choose the manufacturing accordingly. Say, for example, if we take a component that you would like to produce thousands or millions per year, then probably additive manufacturing might not give you that right business case here. So then we would recommend to go for a traditional process. And of course, Pelagus can support in both traditional and additive manufacturing. So we have a network of manufacturers who we use depending on the demand. Demand, I mean where and when the product is needed. So we choose the appropriate manufacturer who is qualified to produce these components, and we make sure that the quality of the components that is delivered is of utmost to the application.
So on demand, meaning, does it mean that when the vessel is coming to a harbor, that the spare parts are already there? Like what, you reduce the downtime of anything, or how does it work? Is it only spare parts or is it also other parts?
It can be any component, any structural component. Obviously, we cannot 3D print circuit boards or monitors or any electronics as such, but any mechanical structural components we can support. And you asked about on-demand manufacturing, right? So the idea is that when a vessel is arriving into a port, and if they let us know what components they would like to have as a replacement, or they don't have the spare at the time, or can be any reason. So depending on the product and the certification required for the product and the complexity of the product, we can manufacture it close to the point of need. But obviously, it's not as simple as that. So for a non-critical component, yes, this is perfectly doable because you don't have any certification, you don't have any critical inspection required. But in case if it is a class approved part, then we will have to produce it in an approved facility. It has to go through certain inspection process to provide, which means it's a little bit longer in terms of lead time to provide this class approved components. So we'll have to plan it accordingly. It's not that we cannot do it, but we have to plan it accordingly. So if the vessel needs an impeller that is class approved, then we know how many days it's going to make, and we would recommend that they let us know this in advance, so we can and we have already delivered multiple components as such. But obviously, any component that the vessel might need, so we can look into it and then see how we can deliver it as fast as possible. Let's take an example, right? I mean, it's not just the normal life is not always regular, smooth flowing. And say, for example, we had situations where we had the vessel being blocked in the Panama Canal, and the supply chain was uncertain, right? So what do we do in those uncertain times? And how do you get the space that you really want? Because now you don't have a regular supply chain that is working. So now we have local manufacturing, which means we can produce the component when and where needed. So if a vessel needs a component on the other side, what we can do is we use the suppliers there, manufacture it, and deliver it on time. So this on-demand manufacturing is not just about reducing lead times and improving your, but it's also about these uncertain situations where you might have some challenges. We'll support you in delivering these components on based on the demand.
Is there any misconceptions people typically have about 3D printing that you like to clear up?
Yeah, this is a fun thing because yes, there are a lot of misconceptions. Let's start with everyone believes that it is a push of a button and then you have the component readily there. It's not as simple as that because it needs a considerable preparation time in terms of the depending on the product material and the geometry and the technology that you produce. So there is a significant preparation time, and this is why for the different components we work with the OEMs, we try to onboard the components to our platform and make it ready. We do our assessment, our engineers perform this assessment, and they identify the right technologies and inspection processes for this, and also associate suppliers for this, which means now when the vessel needs this component, it is ready to go, and then we can manufacture it fast. And then there's also this misconception saying that our 3D printing components or additive manufactured components are not strong enough for functional usage. Here, there are multiple material and multiple technologies that we can choose depending on the functionality, which means in some cases it can even be stronger than the traditional processes. Say if we are producing or comparing this with a propeller blade or a side thruster blade, where in regular casting process we get the material density from 40 to 50 percentage, and then there is this conventional issues related with casting like blowholes and pinholes and all these things. And in additive manufacturing, when we produce a component, we can eliminate this regular defects that might occur along with this, and it also has a material density up to 90% or even more, which means you have a strong blade which can last longer as well. So this is how it differs. And then there is this misconception then that 3D printing is cheap, which is not always the case. But yes, I mean, if we can manage to redesign the component for functionality, because if you take a component that is designed for conventional process and you use that for additive manufacturing, you might not see significant cost reduction. But if we can redesign the component, then add some value to it, create like say for example the component can be made lighter, or we could include more features to these components, then the higher price that you pay is justified, right? Say for example, we had a case where we were able to achieve up to 90% in material reduction for a component. And the component's original weight was 75 kilogram. And we were able to redesign the component, which was 8 kilogram in final size. Here,
Wow. I just have to repeat that. So from 75 kilograms to 8 kilograms, that's huge. How is that possible?
Yeah, that is designed for additive manufacturing, right? So what we do is, like I said, we use material only where it is needed. That is one. And then you have this advantage of producing complex geometries without any additional cost to it. So what do I mean by here? We have this original valve, which is a block valve that is mounted on top of a two-stroke diesel engine in the vessel. So this 75 kilogram valve, in the traditional process, we could only manufacture using casting, and then you have to drill straight holes because you cannot have curve machining and for flow channels. So what happens here? What did we do different here is we took that flow path and then we created an organic shape for better flow, and we took the material thickness that is only needed for handling the pressure of the flow and the fluid here, which means you have material only where needed. So by doing this, we were able to reduce 90% of its material simply because of choosing a different manufacturing process. In 3D printing, we are able to achieve this, and we have demonstrated this, and the component is installed in one of Wilhelmsen's vessel, which is right now sailing as well. Yeah.
And you mentioned OEMs. So as far as I understood, you work closely with OEM, you're not competing with them.
Exactly. So and especially this example that I just mentioned, it was performed along with the OEM, because here when the OEM was not able to deliver this component on time, so then Wilhelmsen needed this component for the vessel. When Kawasaki reached out to us, we were able to identify the potential in redesigning it, and we redesigned it, and we had multiple discussions with the design engineers from the OEM, and then we were able to finalize this design along with the OEM, and depending on the vessel was going, we were able to choose the supplier close to the port, manufacture it, and then deliver it. And here, something that we are proud of is that the vessel was in the port only for 8 hours, which means we had to plan everything in such a way that the component has to be manufactured, post-processed, and then delivered. So everything was able to be done because of the planning and the setup that we have established. And we also, since Wilhelmsen is one of our partner, so we were able to use our warehouses and last mile delivery using Wilhelmsen's services. So we were able to deliver the component on time, and this was installed. And it's not just about the material reduction of the valve, right? So here, for the 75 kilogram heavy valve, you need special equipments to hoist the valve and then mount it, which means there is labor intensive installation process. And now with this reduced weight, you don't need that equipment, which means the installation time is reduced, the overall operation time is optimized, and there's no stress on the operators. They don't have to. You're bringing in a safer working environment here. So these are the other advantages that is not directly seen, but that you can experience when we do these projects and have this kind of optimized products.
Wow, that's really a very clear success story. What kind of key challenges could you face in ensuring the clients fully benefit from such a digital solution? Because this is really digitalization we are talking about.
Exactly. Like I said, the whole process is orchestrated using our platform to make the end user or the OEM aware of this technology, because like I said, it is something new that they are trying. So it needs a little bit of hand holding and showing some use cases and things like this. So the technical challenges is always there, and then you have all the different processes in terms of approving this new way of manufacturing, which can be a little bit tedious depending on the size of the OEM or end users. So this is one of the challenges. And then I would say cost is still slight challenge, because additive manufacturing components can be a little bit expensive than the traditional processes for various reasons, of course. And we need to identify the right cases that can bring value, just like the use cases we talked about. So then you see the total cost of ownership of the component is much reduced or optimized. So now the component is digitally stored in our digital inventory, which means you don't need to store multiple components of this in the warehouses, which is optimized, right? You don't need to have those physical components. We can manufacture when and where needed. Say, for example, if the customer in Brazil needs this component, we don't have to ship it to Brazil. We can manufacture locally and deliver it, which means you optimize all your warehouse and also all the shipping and customs cost that's involved. And different countries have different processes. Of course, when you have a large volume of components that you are currently doing, it's not easy to replace everything overnight. But there's always this opportunity we can address, we can take, and then one after the other, we can digitize this for all the critical components that you have challenges currently. And then this digitally stored component can be used for manufacturing wherever you want in the world. It can be South America, it can be North America, Africa, any country, anywhere. We will be able to manufacture and deliver the component for you. So this is how we establish that value and create that value for that additional cost of the component.
As far as I heard, you have also ongoing project regarding measuring of footprints, CO2 footprints, which is really crucial in today's reporting system. So can you tell a bit about that one?
It's a exciting project that we are doing along with the Norwegian Research Council. So the project is called DAVAMS, Disrupting and Additive Valuing through Additive Manufacturing for Spare Parts. So here, the idea or the scope of the project is that we identify demonstrators and we manufacture using this digital inventory and on-demand processes. And we compare the carbon footprint for traditional process and through this digital inventory and on-demand process. It's an ongoing project. So at the end of the project, we'll be able to provide results and then a principle because the output of this project is going to be a tool that can calculate and then show you the difference between traditional way of the supply chain delivering a component and this on-demand manufacturing. So this is what we are trying to achieve in this project.
What are some innovative uses of 3D printing that you find particularly exciting or transformative?
Technology is quite mature, and then of course we keep exploring the technology itself, and then there is new materials and there's new processes that we can always bring. Since we don't own any machines and we onboard manufacturing partners, if there is a new technology, a new material in the market, we immediately onboard them and make it available for our customer wherever they are. So for Pelagus, the next 5 years, we are looking forward to be that company that offers a one-stop solution for manufacturing using on-demand processes. For us, for Pelagus 3D, success is to have an impact on the industry, maritime and oil and gas industry, to provide and to become the leading on-demand manufacturer and to have the largest digital inventory for the industry. And how we do this is through our innovation and then this global expansion of adoption of additive manufacturing and digital inventory solutions. So this is what I believe is success for Pelagus 3D. And of course, we are looking forward to work with as many customers in this industry to have them or support them in making their lives a little bit easier. We know that the conventional supply chain can have its challenges, but we need to be prepared for that. And for that, we need to start now in terms of identifying the right products, the critical components, and then also improving the current state, like how I shared this example of the valve. There are many use cases that can be an inspiration for the customers and to see the potential that Pelagus 3D can offer. in terms of optimizing the supply chain or the product functionality.
My last question is, so we talked a lot about success and your job as a success manager, but what is success to you?
Success to me is a happy customer, a customer who is satisfied, and also looking for opportunities where we can continue to work together, right? So Pelagus 3D, we don't just offer 3D printing. We have multiple services. So when you log into our platform, you can see that all the different services that we provide in terms of, say, for example, if you need to do some scanning or measuring, or if you want to have a class approved component, or it can be any services for the maritime and oil and gas industry that we can provide. So success for me is Pelagus 3D being that hub, building that ecosystem to bring everyone together and work seamlessly. So the people working in the asset or the vessel, if they want to have a service, they don't have to look for anywhere. They don't have to talk to multiple people to get a quote. And so all this can be done through the platform. So success for me is when they have an issue, when they have something in mind that they want to do, they should think of Pelagus. So that is success for me.
Yeah, that's a really clear goal for the next years to come. Thank you very much for your insights. And I also picked up a word I haven't been thinking about, but of course that's very valid, and that's digital inventory. Never thought about it, but that's so logical.
The digital inventory has been around for a while now, and we can see a lot of oil and gas operators particularly interested in digital inventory. The reason being simple, because the cost of downtime in a platform, in an oil and gas platform, is huge. And if that happens because of non-availability of spare parts, then it's not a good situation to be. So having this freedom or flexibility of having the components to be able to manufacture on demand is really critical. And also on the other hand, you can see there are warehouses full of components, and these components are rarely being used. And say, for example, here in Norway, Equinor says that almost 80% of the components in the warehouse has not been used for the last 10 years, which means you have multiple components that you have purchased, and there's maybe, instead of buying to be safe, you buy for, and you find out that you don't really need that now. So there are different reasons for this, but when you digitize it and you have a digital inventory of these components, your capital is not locked in your warehouse, right? So then you can plan efficiently. So this digital inventory is enabling you, provides you that extra layer of safety in terms of availability of your spare parts, and optimizes your supply chain.
Yeah, it's so logical. Thanks a lot, Parthiban, for sharing these insights. Thanks a lot for attending HANSA Newscast.
Thank you, Yanni. It was a pleasure talking to you, and thank you for the opportunity. It was great discussion.